In this video, we are going to explore what the term mole means in chemistry and how we can use a particular formula to convert between the number of moles, the mass of a substance, and its relative formula mass. Now, although the word mole might sound a bit strange at first, it is simply a unit that chemists use to measure the amount of a chemical substance, much in the same way we use meters to measure distance or seconds to measure time. So, when we say we have 1 mole of a substance, we mean we have an amount of that substance that contains approximately 6.02 times 10 raised to the power of 23 particles. These particles could be atoms, molecules, ions, or even electrons, depending entirely on the substance being discussed. For example, if you were handed a small pile of pure carbon and told that it contained exactly 1 mole of carbon, then what you would have is a pile consisting of 6.02 times 10 to the 23 carbon atoms. This incredibly large number is known as Avogadro's constant. The reason this number is so specific is because it turns out that the mass of that many particles of any given substance, when measured in grams, will numerically equal that substance's relative atomic mass or its relative formula mass. In other words, if carbon has a relative atomic mass of 12, then 1 mole of carbon atoms will weigh exactly 12 grams. Similarly, 1 mole of oxygen molecules, which have a relative formula mass of 16 times 2 making 32, will have a mass of 32 grams. For carbon dioxide, which has a relative formula mass made up of 12 for carbon and 16 times 2 for oxygen, giving a total of 44, 1 mole of carbon dioxide molecules would weigh 44 grams. The key takeaway is that in each of these cases, you would still be dealing with exactly 6.02 times 10 to the 23 particles, regardless of their type or identity. Thanks to this useful principle, we can use a formula to work out the number of moles in a given sample. The formula tells us that the number of moles is equal to the mass of the substance divided by its relative formula mass, usually denoted by the letters m and r. Let's consider a practical example. Suppose we have 42.5 grams of ammonia, and we want to find out how many moles this represents. First, we calculate the relative formula mass of ammonia by adding the atomic mass of nitrogen, which is 14, to the masses of 3 hydrogen atoms, each with a mass of 1. This gives us a total mR of 17. Then we divide the mass, which is 42.5, by 17, giving us 2.5. This tells us that we have 2.5 moles of ammonia in our sample. We can also rearrange this formula to work out the mass if the number of moles is known. For instance, if we are told that we have 3 moles of carbon dioxide and we need to find the total mass, we simply multiply the number of moles, which is 3, by the relative formula mass of carbon dioxide, which we already know is 44. This gives us a total of 132 grams. Furthermore, we can take this calculation a step further and find the mass of a particular element within a compound. For example, if we want to know the mass of carbon present in those 3 moles of carbon dioxide, we take 3, the number of moles, and multiply it by 12, the atomic mass of carbon. This gives us 36 grams of carbon. Since the total mass of the carbon dioxide is 132 grams, we can subtract the 36 grams of carbon from it to determine that the remaining 96 grams must be from oxygen, which makes sense given the molecular formula of carbon dioxide. Finally, it is important to understand that chemical equations can also be interpreted in terms of moles. When you see a chemical reaction written out, the coefficients in front of each substance can be viewed as the ratio of moles involved in the reaction. For instance, in a reaction where 1 mole of magnesium reacts with 2 moles of hydrochloric acid, the products will be 1 mole of magnesium chloride and 1 mole of hydrogen gas. These ratios help us predict how much of each substance we will need or produce. So, if you started with 2 moles of magnesium, you would need 4 moles of hydrochloric acid, and you would produce 2 moles of magnesium chloride and 2 moles of hydrogen gas. Understanding the concept of moles and how it relates to mass and formula mass is incredibly important for stoichiometric calculations in chemistry and helps in determining how substances interact and transform in reactions. That concludes our discussion for today. We hope you found it informative and useful, and we look forward to seeing you in the next lesson.